Okay, welcome back to our lessons on making the game a Breakout in Greenfoot. We're going to continue with working in the ball class. Currently, our ball, when we create the ball, we set a rotation direction. Remember, the angle starts at 0 degrees pointing to the right and rotates 90 degrees down, 180 to the left, 270 straight up. So we're setting that rotation. And then any call to the move method of this actor will move it in that direction. This actually is the standard mathematical way of defining an angle. 0 degrees is considered to be the positive x-axis, and 90 degrees is considered the positive y-axis, and so forth. And since y's are going down, that's the way it is. All right. Our act method currently has if on wall bounce. And we need to add some more logic to this method. We need to add if on brick bounce. And it's at this moment we're going to also end up adding some sounds and such like that. So there'll be some nice things we can do. We can add some wall bounce sounds as well, but I think I'll leave that as an exercise for you. So let's go right here to public void if on brick bounce. If you recall, in our last lesson, we made some methods that kind of help us. We could even make these methods private since there's really no reason for any other class to call them. But I'll just stick with our general procedure that we've developed that methods are always public. I think that's just an easy way to remember it for now. But you see we have moving left, moving right, moving down, and moving up. And those return true or false based on what is doing. And we're going to use that to our advantage for sure. All right. So what I'm going to do, let's discuss the strategy first, okay? So if you don't mind, I'm just going to take a little snapshot of that I have over here of some bricks that we could have made. All right, so if our ball is coming like this, then relative to the ball, the brick is where? It's up above, right? And so this yellow brick we would access with the actor method, get one object at offset. So the get one object at offset allows us to access an object that many cells away. So we'll use get one object at offset 0, -1. Remember, negative y's are going up. And I'm going to call that the up brick, okay? Now, for us, you might be wondering, well, wait a minute. One cell up, won't that look like the ball's not actually hitting the brick? Well, remember, our cell is 1 pixel. So unless they're playing with a magnifying glass, they're not going to see that, right? Okay. But also in this game, it's going to be possible for the user to send the ball, I don't know, like this. And it like maybe hits the side and then hits the top and then comes down like this. So it could also hit a brick coming down, right? And the way that our ball will bounce will depend on how it's hitting it. We also need to consider, what if we come at the wall like this, bounce off the wall, and then hit from the side? Well, in that case, the ball's going to bounce like that, right? So we have all these different ricochets that we have to consider. And we also have to consider from the left as well. So let's get right to it. I'm going to look for a brick in the up direction. And I'll start with this, although we will get an error, but I want to talk about what it is. So get one object at offset, the way that the method is written, and it has to be this way because it's not like a list or something like that. When we use list, it actually, if I ask for like the world method get objects at XY of type brick, it actually returns a list, and lists allow you to dynamically, like on the fly, change the type. But just simple one objects do not. So the get one object at offset, the only thing it can return that as is an actor. Okay? So we have to be the ones to cast. So this is how you cast. Okay? You're going to see that I'm going to get an error here. It's going to tell me incompatible. Greenfoot actor cannot be converted to brick. Why? Well, because not every actor is a brick. Some actors are a paddle, right? But we can do this, but you only ever want to do this if you know for sure that this is going to work. Otherwise, it will actually cause the program to runtime error, which will shut down your program, your game in the middle of the game, right? But we know because we said this to look for class type brick, we know it will be a brick. But I want to show you that you don't always have to cast. What if I decide instead that I want to make another actor called up2 that's a reference to up? Notice I will not get an error here. Well, that is because every brick is an actor. Because brick subclass actors. So not every actor is a brick, but every brick is an actor. So Java allows me to make something into an actor without having to cast it. Okay? I mean, I can. I can do that, but I don't have to. Right? But I do when going from actor down the brick, which is fine. All right, let's get a brick down as well. So that's in the Y direction. Okay, at this point, I'm going to go ahead and process the up-down before I get left and right. And the reason why is there is a possibility that, let's say I was going up here, right? And while I'm going up, we're not moving 1 pixel at a time. So it could be that I was kind of 2 pixels away, then the ball moves speed and actually goes into this brick. At this moment, there's a brick up, and there's a brick also to my left. If I look 1 pixel up from the ball, or 1 pixel down from the ball, let me zoom in a little bit. Can you see that I would actually store in a left and up the same brick? So if I then remove this brick because I'm colliding with it, and then try and remove the brick again with the left, then I'm going to be removing an object that's already been removed. That's going to be an error that will cause the game to shut down. So if I want to be really careful, I would do them all one at a time. But through experiment and thought, I've realized there's no chance that I'm going to have a ball 1 pixel away from a brick, both above and below, and have that be the same brick. So it hasn't been a problem, at least not yet. But it is. I guess it could happen. We should. You know what? I'm going to change it. I played around with it and I never got an issue, but it just bothers me because it's just not safe. So I'll tell you what I'm going to do. We're going to do it one at a time. So I'm going to say if up is not equal to null. So we're going to handle that first. So we're going to do them one at a time. I think that's good safety. Even though, like I said, I played around with my own, and I never had a problem with it. So remember, the get one object at offset will return something. It will return a brick. But it is either an actual brick or a null brick. So when I say if up does not equal null, what that means is that we have detected a brick that we are entering. So I'm going to simply say get world dot remove object up. Okay, so now what I want to do is I want to make a sound. All right, so if you haven't seen this before, there's this guy named Kenny. Not Kenny Burrell, although he's awesome. You should really check him out. But Kenny Assets. And it's this guy who he's made a career out of giving out free, like, platformer for basic 3D even, and basic 2D games. And they're all in type PNG. And they are so well done. And they have, like, actors that have all their different movements so you can animate jumping and walking. So I want to use a lot of Kenny's assets. You'll notice he sells them, but he actually gives them away all for free. And he says right there when you download it, he says this is free to use even if you make money. He says I appreciate it if you cite me, but you don't have to. So it's completely open source. And yet he's still making money because people like it so much they just give him money, which is so cool. And you can see he's also got some games and some tools. But he's got audio, which is also nice. And the impact sounds is a nice download to do. He's got lots. The casino one is good too. It's got like lots of different ones. So here you can just sample them. But if you click on this download, then we'll be able to download them. Okay. And I have already downloaded them, and I made a folder called Sound Packs, okay? Where it comes in as a zip, and I simply extracted them there. So all right, so I've got the Kenny Impact Sounds up my folder here, and they're all right here. Now they're video files, so they may need to be converted to a wave or something like that, but that's a good one that you can use to make so you got footsteps, impact glass, impact metal. So that might make a good one. So anyway, there's some cool sounds there that you can use. That's fine. All right. Alternatively, you can also record sounds in Greenfoot. So if you go here, you can go to Tools, I believe. Yeah, and you can sound record. And you can record your own sound that way as well. Okay, so upon inspection, Greenfoot does not actually support OGG files yet. So I Googled online OGG to wave converter. I met Convertio. I've never used it before, but, we'll try it. And I just selected the file, and I'll convert. I'll download. And I just navigated back to my Breakout sounds, and I'm going to put brick there. But I do need to delete the other one now. So I've got a brick wave file, and I've got, and I'll delete that. So the OGG files are nice. You can also record it yourself, which is, I've done that as well before. But you do have to convert them, and so now that should work. Okay, so after you've got a .wav file, which is supported from Greenfoot, because it still doesn't support OGG yet, which is kind of a shame, but hopefully they will soon. We've got it converted, so let's declare an instance variable for the sound. Okay, so hopefully you have a sound file that you've chosen that you've converted to a wave or maybe recorded your own sound. And I'm going to say make an instance variable, so we'll make it private. And the type of variable, remember when we declare a new variable name, we have to tell Java the type. Well, the type is called Greenfoot sound. And I'm just going to call this brick pop because I might have different sounds for each different impact that is made. For demonstration purposes, I'm actually just going to use the same sound, but I hope you will change that. Now, in the constructor, we should actually make the sound. So remember, when you declare this variable, all I'm doing is reserving that name. I haven't actually made a Greenfoot sound yet. So we will say brick pop equals new Greenfoot sound. This is us calling the Greenfoot sound constructor. And the Greenfoot sound constructor simply takes, in quotes, a string, the name of the file. And that file must be located in your project folders. So here's my Breakout folder for my project with my classes. It must be located in the sounds folder. Okay? You might be able to bring it in from over here. I'm not sure. Yeah, it doesn't look like it. It looks like the only way that you can do that is to have it manually put in go to your folder explorer, your file explorer, and put it in that folder. And we simply put the name of the file with the extension. Mine was called brick pop, I believe. I just opened it. Now I close it. Actually, it's just called brick. So my sound is just called brick. And then mine's a wave file, so I put .wave. And there we go. All right. Just a word of caution, by the way. You should not convert full-length songs to .wave files. .wave files are non-compressed. So if you were to convert like a song, like a 4-minute song to a .wave file, you'd be using a lot of gigabytes of space. So that would be a bad idea. All right, I'm now ready to add the sound effect to my bouncing off a brick. So if the up brick was not null, that means we encountered a brick above us. So we remove that brick from using the world class's remove object. So get world returns the world class. Yeah, I should probably go over this. I could say world W equals get world. Get world returns a world. Okay? Let me pull it up in the actor documentation. Get world returns world. Which world? The world we're dealing with. Typed as a world. And the world class contains the method remove object. So that's exactly what I'm doing. I am getting an instance of the world from get world and then simply calling remove object. However, I don't need this W reference to my world anymore. So I can just get what I call an anonymous instance of get world. You know, I don't give it a name. I won't be able to call it later. I just get it for one mere second in time, or nanosecond, if you will, and use that get world to remove the object. Now I'm going to play my sound, and that's brick pop. There is several methods. You can look them up in the documentations for Greenfoot, but the one I'm going to be using is simply play, which will play the music till it ends. All right. Now, let's handle the down method. If down does not equal null, well, then we need to remove that object. And we need to play that sound. All right, let's get another break. I'm going to get the one from the left, so that's -1. And see, we're doing this one at a time so that we don't actually have get one object at offset to the left and up give us the same brick. If we try and remove the same brick twice, we'll have an error. So if the left brick and the down brick happen to be the same, the down brick got removed, so the left brick would no longer detect it. All right, so let's handle that. If left does not equal null, then we'll get the world and remove the object from the world. Remember, remove object is a method not in actor. The remove object is in world class, so I have to call it on an instance of the world. The play method is in the Greenfoot sound class, so I have to call it on the instance of the sound, which makes sense because I could have multiple different sounds, right? And I have to tell it which sound I want to play. All right, let's get an instance of a brick to our right. And if right does not equal null, I will remove the object. And I'll play my sound. At this point, we need to make a decision. We can get extremely detailed with how we handle collisions, and you've probably heard me mention before that collision detection is just terrible. I think Greenfoot does a great job with it, but collision detection is just really hard. Anyone that's played enough video games have seen their characters walk through a plant a few times. I mean, it's difficult. Well, what I want to decide is how am I going to handle situations like hitting two bricks at once, or hitting the corner of a brick. You know, if I hit this corner here, do I want my ball to bounce off like this? Or do I want it to bounce off like this? Which one is it? And understand that, you know, because of the movement of our ball, we're probably not actually hitting that corner exactly. We're probably detecting the collision after we've already moved some ways into this brick, you know, a pixel or two, right? If we're moving 5 pixels at a time at an angle, it could be 2, 3 pixels. So we could detect that we are hitting this brick in more than one direction. So we need to decide which one to dominate. If we want to be more precise, we could even code the location within the brick and go in there and make it, you know, hit the corner and actually ricochet right back. There's lots of different things. You can get more and more detail in the code. But what I am simply suggesting that we do is that we let up, down dominate left, right. And that if you hit a brick at all above or below you, that it will bounce off in like it's bouncing off the ceiling. So that hitting a brick on the side really requires you to hit quite a bit into the brick itself. So that's what I'm going to do with the code. And the way I'm going to handle that, remember from our if on wall bounce that when you hit the ceiling, you have to rotate 360 minus get rotation, and I ask you to go through the geometry on your own on that. So it doesn't matter if you are hitting the brick from below, it's 360 minus your angle, right? So that, this angle here would be probably more like 300. 360 minus 300 is 30. So, this angle here is 300 degrees that way, and this angle here is only 30. So you see it works. It works the same way if you come from the top and below. So like if this angle here was maybe 120, 360 minus 120 is 240, which is exactly what this angle is coming out at, 240. So it doesn't matter if we're hitting from below or above. That's a big win for us. We just get to ask that, but we're going to ask that first. So if down does not equal null, or up does not equal null, we're going to say set rotation 360 minus get rotation. All right. Else, and we can play around with that. You can either say another if statement, which is going to allow left-right impacts to happen at the same time as up-down. Do it both ways. I've tried it both ways. You may not see a difference at all, but it has very special cases where this happens. But I'm going to make it to where it does one or the other in this way. So I'm sorry, I need to do else if. Else if left does not equal null, or right does not equal null. Remember, we have the same formula for bouncing off of a wall on the left or right, which is what we're essentially doing for whether left or right. If you recall from when we coded the wall in the last lesson, that's 180 minus the angle. All right, so that's how that's going to work. All right. So I think we've got our ball bouncing off bricks now. All right. Now it is time for us to make a paddle. The moment we've all been waiting for. So let's make a paddle. New actor. New subclass. Paddle. Once again, part of this entire activity has been about drawing images, so we are not going to select an image, although they probably have a nice one for us. We're not going to do that. We're going to make our own in the code. Which is good, because the code for making an image is pretty much the same way you would make an image in basically every Java graphics package that I'm aware of. So let's make a constructor. Well, you know what? Before we do that, though, I don't want any magic numbers. Y'all know I do not like that. So we're going to define a width of our paddle. And it doesn't matter that I'm using the word width again here, because remember, outside of the class, you have to call a static variable with the name of the class. So if I was using it in, say, the ball class, it will be paddle.width. If I wanted the width of the game, it'd be breakout.width. So it's very clear which one I'm doing. And I'll let height be 15. All right. All right, remember the first line of code is that in any constructor. That's the first line of code. So if I want to change how this happens, I got to put some parameters there. But I'm not going to, so I'll go ahead and leave it off. Just remember that it's there. So the first thing it's going to do is call the actor class to make my paddle an actor. Now I am going to create an image. Notice I am not declaring this variable outside of the constructor. So it's not going to be an instance variable that survives for the length of the object. I'm just making a temporary variable to do a little work. I'm making a Greenfoot image. So to make I'm making a new variable. So I say the class type, give it a variable name, and so I call a constructor. All right, now we've got an image. I'm going to set the pin color. This is a little confusing because it looks like I'm setting the image color, but it's a method in the Greenfoot image class that sets the color that you're going to be drawing with. And I am just going to make my paddle a dark gray. And you can play around with any other color you want. Okay, and now that I've got my color set, I can now call the fill method, which will fill the entire image with the color that I have set. And finally, I'm going to set the image of my paddle to image. Now remember, the set image method is in the actor class, so I can call it just saying set image since I'm in an actor class. All right, so now what I'd like to do is I would like to make my paddle respond. And first we're going to do it in kind of a stupid way. Then we're going to do it in a smart way, but it's always important that you see. So I'm going to say if Greenfoot dot is key down. So just like the mouse commands, the key commands is tied to Greenfoot. It's a static method in the Greenfoot class. I'll go to my Greenfoot class documentation, and I'll pull that up. All right, so most of your helper methods are in the Greenfoot class. Notice they are static. So is key down is the one we're using. It takes a string key name. Static methods are not called on an instance of the class. It's called on the name of the class. So for that reason, I am simply going to say Greenfoot.isKeyDown. And I'm going to use the left arrow key. You can use WASD if you prefer. I'll be doing that. And I'm simply going to take the actor and set location to get X, comma, or get X, if I'm going left, minus 5, and get X, and then get Y for the Y value. And now I will say if Greenfoot dot is key down right, then I'll say set location get X plus 5, comma get Y. And let's compile that. Oh, I'm missing a parenthesis. All right, just one thing I want to point out actually before I forget. Greenfoot.isKeyDownLeft returns a Boolean. Boolean. So it returns true or false. So this will either be true. So this reads either if true or if false. If this is true, it goes. A lot of people are still doing this move, saying equals equals true. That's fine. That helps you to understand it, but it's not necessary because this will evaluate the true or false. If you want to do something when it's false, just put a not operator in front of it. And I like the way this reads. It's saying if left key is down. All right, let's see how we do this. All right, so I'm going to make a new paddle, and I'll put it there, and I'll hit run, and I should be able to move. And now, if you move all, you notice though we can go off the screen, and the reason why is because the XY location of this paddle is in the center of the actor. All right? So let's go and make this better. But hopefully at this point you have a moving paddle. All right, let's go back to the paddle and let's make this better. Okay, there's several things I don't like about this. First of all, what do I call that thing right there? That, my friends, is a magic number. A number without any context whatsoever. So I could simply make a variable right here, and that actually helps because then I know that it's the speed that it travels when I look at this method. But that means I have to find the act method to control the speed, and I want to make speed changing, since it's a important part of the game, I want to make that a variable that is clear and obvious from the beginning. So we're going to make it another constant. And 5 is the number that I've chosen. So now you can play with the speed. You don't have to go and search code. Remember, we're doing some pretty simple projects, but if this code was thousands of lines of code, that's where you want to make your changes. Right there on the public constants. They show up in the documentation. That's where we want it. So we'll use, for going left, we'll say minus speed. For going right, we'll say plus speed. But I'm going to do this in a different way as well. I don't like this idea of setting my location more than once. The setting location, let's only do it once. And instead, let's calculate our location. So what I'm going to do is I'm going to make something called dx, a temporary variable dx. Dx simply means delta x. So delta stands for change. So change in x. And the default is 0. If the Greenfoot left key is down, I'm going to set dx to, I'm going to subtract from it speed, making it negative speed. If the key is to the right, I'm going to say dx plus equals speed. That way, if they press both the left and right key at the same time, we would simply have a speed of 0. I could simply say equals, right? But if I do that, then pressing the left and right key would actually make it go right. If I just said equals negative speed and equals speed, that means that if they press left, it's going negative 5. But that if they're also pressing right, since it's the second line of code, then it would make it default to right. And I don't want to do that. So I'm going to minus from the dx and plus. You may also notice that I am not using elif here. That's because most of the time when we play games, we oftentimes, if we're moving right, we'll then decide to go left, and our fingers will still be on the right button when we start moving left. So we don't want that. We want it to just switch over. All right, so now that I've calculated the change, I'm going to go ahead and do that. I'll say set location, and I'll say get x plus dx, comma, get y. Next, what I want to do is I want to add some conditions here so that we don't run out of the screen, right? That's not really particularly very cool. So we're gonna add an and. So I don't want to move to the left so that my paddle goes off the screen. That's very disconcerting to us. So get x is the center of my paddle. We made a constant called width that is the width of our paddle. So I will simply divide width by 2. Now, get x minus width divided by 2 is the far left coordinate of our actor. I need that to be greater than 0. So I am adding a new requirement. And remember, the and operator requires both of these evaluate the true. So in order to move left, you must have the left key down, and you must be to the right of 0. In order to move right, you must have the right key down, and you must have room to move right. So if I say get x, which is the center of my paddle, and I add width divided by 2, that needs to be less than the width of the game. The width of the game is a static constant from the Breakout class, so I call it on the name of the class because it's static. Breakout.width. All right. Now I think that is a well-made paddle class. So the next thing we need to do is to do the logic for bouncing off the paddle. All right, so here we go back to ball. Time to program that. So we've got if on wall bounce, if on brick bounce. We also need the handle if on paddle bounce. And remember, all of these if on bounce stuff, we're not actually moving in them. We are just changing the direction. The move is handled on that last line. So if on paddle bound, if on paddle bounce. And so here we go. Yes, it's mad at me because it doesn't exist. And remember, we're calling a method in the class that we're working in, so I just call the name of the method. If on paddle bounce. Okay, so we want to be very careful with this, y'all. We dealt with this issue a little bit with the wall, if you recall. But we need to make sure that we deal with the same issue here. When we hit the brick, we didn't have to worry about that. Because if you hit a brick, the brick disappears, so you can't hit it again. But when I have a paddle, okay, and I'm just going to draw a super big one, okay? And let's say I'm going to use a green ball, okay? So let's say that my ball comes down, and this is the moment in my game, okay? And this is a perfectly reasonable situation. We are not moving. We set our speed to 5. We are not moving 1 pixel at a time. It is totally reasonable that we could detect the ball hitting the paddle at this moment. If I tell the ball to then do 360, and I think you remember, right? That's going to be 360 minus my current rotation, right? Which is get rotation, but I'll just say rotation. If I do that, then the ball, let's say it was coming like this, the ball's angle now will be like that. But if the ball is coming at a steep enough, at a flat enough angle, okay? So let's say that the ball was coming at an angle like this. There is a very good chance that on the next frame of the game, I'm going to do a different color, like a lighter green here. There's a good chance that that ball is still touching the paddle in the next frame. In which case, what's it going to do? It's going to say, oh, I'm touching the paddle, right? I better 360 minus rotation. And then it starts going down again. And so what you get is this ball that on the paddle. And you'll see that a lot of times when people try and code this because they're not considering that. But we're not going to make that mistake. Or I should say I'm not going to make that mistake again because I learned from my mistakes. Okay, so here we go. We're going to handle the moving down. That's if moving down. That's the key. If the ball's not moving down, then we're not going to worry about bouncing off the paddle. That's how we handle that. And get one object at offset. And I'm actually going to look 3 pixels away this time from just experiment. That's what I thought was appropriate. Notice I'm not keeping a reference to the object down. I just ask, hey, is it null? That's all that matters. Then I'll simply set my rotation to 360 minus my current rotation. Which, remember, get rotation and set rotation are methods in the actor class. I'm in a subclass of actor, so I just call them directly. Okay, we're now ready to go to our breakout class. We are, by the way, there is something I'm going to add to that method in just a second that makes it a little bit more fun. But for now, let's just test it out. So let's go ahead and add our paddle to the game now, and our ball. So I'll say ball B equals new ball, and we could definitely introduce some randomness. We could use greenfoot.random here. But I'm just going to say negative 60 for now, and I'm going to leave that as an exercise that you add some randomness there. And so I'll call the add object method in the world class, add object. Remember, when we added an object or removed an object when we were in the ball class, we had to say get world and then call that method. But now I'm in the world, so I just say the method. That's the difference. I'm adding the width, and I'm going to put it at the center, left and right, and 2/3 the way down. By the way, notice that I'm multiplying by 2/3 afterwards. If I put 2/3 in front of height, I would actually be multiplying by 0 because 2 divided by 3 is 0 since they're integers. But this add object method takes an integer, so I need to use integers. So I multiply by 2 first and then divide that by 3, so it's not going to be 0. All right, let's get the paddle. So that's we're making a paddle, so I tell Java, okay, I'm making a variable of type paddle, call it P. New paddle. And I could probably do this all in one line by putting new paddle right there, but I'll just say P. And again, we'll start at the middle of the XY. And I like 7/8 of the game down, but you can certainly play with that. Again, try and avoid magic numbers as best you can. But height 7/8 is very readable. Oh, 7/8 the way down, so that's I wouldn't call that magic numbers. All right, let's see what we got. All right, let's check it out, and I'll run it. All right, and so that should be a lose right there, shouldn't it? All right, let's go back to our paddle, our ball class. We're going to add a little bit of nuance to this. So the if on paddle bounce, that's great. I like the set rotation, but I'm going to do something else. I'm going to allow for pushing, which is an important strategy in the game. Otherwise, you're actually just locked in a continual pattern without any way to affect the ball. So we're going to start with the push being set to 0. This is in the ball class. And we're basically going to be doing exactly the same thing that we did in the other class. We're going to make a variable set to 0. If you're going left, we'll subtract from it. And I know that's a magic number there, but that's okay in this case. Is key down right. I'm going to add 20 to it. Now, what I'm going to do is I want to make sure that my rotation is not going to alter up down. Okay, I don't want them to completely break the laws of physics here. So this is going to be a kind of an unusually long if statement, but bear with me. I'm going to get the rotation of the ball. I'm going to add push to it, and I'm going to make sure that it's still less than 360. and greater than 180. So remember, 180 degrees is directly to the left. 360 would be all the way to the right. 360 is the same as 0. I don't want a push to cause a ball that's supposed to be bouncing back up to all of a sudden start bouncing down. That would be not cool. So I just do a little bit of a check right there. And as long as that's okay, and again, that would be a very exceptional situation that may or may not come up in the game, but we want to handle it. So if that does happen, then I'm going to alter the rotation of the ball a little bit more by 20 degrees. And, again, we should probably make a constant for that 20 degrees called like push effect, something like that. But for now, I'll just leave it. Okay, so now let's go ahead and run it again. So let's see what we have. Reset. Let me run this. So you see I was able to push it there. So the paddle has to be moving during impact, which is actually a little bit challenging, but a neat part of the skill. So now it's moving very flat, and I don't like that. So I'm going to try and bounce it back up a little bit more. So I can adjust the and I lost. So I'll run again. Oh. All right, so I want to do a little experiment. I want to take out this brick pop play from each one of these situations here, and I want to instead control brick pop in one if statement at the end. And instead of just play, since the play command only will play if the sound is not currently playing, I want to stop the current sound and then play it again. So what we'll get is like if it could be midway in the pop sound, it'll be like pop pop, when it hits two bricks really quickly, as opposed to just making only the one sound, which is a little disconcerting. So I'm going to ask if any of the bricks were there. So that's if left does not equal null, or right does not equal null, or up does not equal null, or down does not equal null. Then I am going to say brick pop dot stop, which won't do anything if it's already not playing, but it will stop it if it is. Then brick pop dot play. And I think that's going to make for maybe a slightly more engaging sound effect. Well, I'm trying to get it to go through a crack, but I just don't want to. Oh, okay, and of course I died. Don't you love debugging games? All right, well, anyway, I think it's working better. So I'm going to stop it there, and I'm going to tell you what you're going to do. You've got a lot of tasks for you, and I'll list them out for you later, but first of all, we should have lives, and after losing 3 balls, you should start over, and as you should have a game over, and perhaps even a game over script that runs. We should have a score. We should have another level where the bricks appear in a different formation after you finish all of these bricks. And finally, I would like bricks to have power-ups. I'd like there to be a subclass of the brick, if you will, would be one way to do that maybe. I'm not sure. I haven't tried it. You might want to make a totally different brick class. But I want some bricks that are, when they break, that they drop a power-up maybe. Or how about when they break, you get more score for that type? Or some bricks could be metal to where they cannot be broken. All they do is you bounce. Another type of brick would be one where you have to, maybe it's covered in ice, so you have to hit it twice. Once to remove the ice, once to then remove it. So those are the tasks that I'm going to be putting ahead of you for you to complete. This was fun, though, so thanks for doing it with me.